Creatine, a well-known substance, which is mostly used by gym goers in order to enhance muscular performance and increase muscle output, is now gaining greater popularity when it comes to brain performance and overall mental health. Creatine is a well-known substance with over 1,000 peer-reviewed papers regarding the substance, indicating its overall efficacy and safety with regards to its use in the short term and also in the long term. The biggest concern with creatine, of course, is taking creatine if you have any renal or hepatic impairment or any severe healthcare conditions. However, overall, creatine is a relatively safe compound. When it comes to mental health, various studies are indicating that creatine actually has various beneficial effects on our brain, on our cognition, our learning, our memory, and also its ability to fight fatigue, especially under conditions of greater mental stress and mental fatigue. Creatine as a substance is a white crystalline substance. It is made up of 3 amino acids, including arginine, glycine, and methionine, and it is mostly stored in our muscles. 95% of it actually is stored in the muscle and 5% of it is stored in the brain. A study which was conducted by Desant et al. In 1998 showed that creatine's uptake into the brain ranges at around 10%. The reduced uptake into the brain basically is the result of the brain's difference in metabolism compared to the muscle. The brain also has a rate-limiting uptake mechanism known as the blood-brain barrier. The blood-brain barrier basically are a group of specialized cells that prevent the uptake of toxins, chemicals or drugs into our brain, therefore reducing the risk of infection or inflammation of the brain resulting in pathology.
Get out.
Therefore, the brain's metabolism, which is totally different to the muscle, makes the uptake of creatine into the brain harder and also less when compared to the other areas of our body. Creatine is a substance which is endogenously made in our bodies. It is created by most of our organs. However, as we age, our ability of making more creatine declines with every decade that passes. The main function of creatine in the body is that of generating a fast energy output and replenishing our ATP stores. Creatine basically offers a phosphate group from the phosphocreatine buffer system to the ADP, therefore regenerating ATP in the process. ATP is an extremely important molecule because without ATP, our cells cannot function, and ATP basically is the currency of the cell in terms of energy. Creatine is available mostly commercially as a white crystalline powder, and it is extremely stable at room temperature, therefore it can last longer when stored outside on your basically kitchen counter. Creatine started being studied from the 19th century. Later in the 1980s, there was greater interest in the molecule and it was being researched mostly with regards to its effects on mental health and mental performance. In order for us to understand how the brain works, first we must look at the pathologies of the brain. As we age and as we get older, from our 20s into our 30s, 40s and 50s, and eventually in our 60s, the risk of encountering a brain pathology is on the rise and it increases with every passing decade. At every basis of brain pathology, there is a disruption of the energy production system. Therefore, there's a disruption in the way we make, use and store energy within the brain. Therefore, most pathologies, including traumatic brain injury, Parkinson's disease, Alzheimer's disease, mood disorders like depression, schizophrenia and anxiety, all have at their basis a disruption in the energy mechanisms of the neuron. The disrupted energy levels in the neuron result in eventually a cascade going down the neuron, resulting in a release of calcium, and this release of calcium, intracellular calcium, causes a release of glutamate from the neurons, which is excitotoxic. Glutamate is a well-known excitotoxic molecule, and glutamate seems to be implicated in neuronal degeneration and degradation. Most pathologies, including Alzheimer's and Parkinson's disease, which happen with age, show a pattern of dysregulated energy systems. Also, mood disorders, including depression and anxiety and schizophrenia, seem to be associated to a disruption of energy within certain areas of the brain, including the prefrontal cortex and the hippocampus. This disruption of energy basis, or the disruption in the energy buffer system of the brain, seems to be at the center of various pathologies, and therefore there's a growing interest in how creatine can actually be used not only to improve our physical performance but also our mental performance, reducing the risk of depression and anxiety, and also helping the brain treat anxiety and depression as a whole. One example where creatine was used in animal models is basically traumatic brain injury. Traumatic brain injury, including concussions or injuries to the head, result in tissue damage to the brain. This eventually results in a cascade and a dysregulation of energy, causing a release of inflammatory cytokines and also oxidative stress that results in neuronal degeneration and death. Therefore, traumatic brain injury, when studied in mice and rats, when creatine was supplemented to mice and rats, for example, over a period of time, the group of mice or rats which were given creatine showed a reduction in the oxidative damage that occurred in their brain. Mice that were injected with 3 mg per gram per day of creatine showed a reduction of around 21% to 36% in the oxidative damage occurring in the brain. This indicates that creatine might have actually antioxidant and protective effects on our brain, therefore it is a neuroprotective agent. Similarly, when rats and mice were fed around 1% creatine per day for 1 month and a brain contusion was applied to the subjects, there was an amelioration of around 36 to 50% in both mice and rats respectively when given creatine. Therefore, the neuroprotective effects of creatine seem to have an interesting potential, especially in maintaining the membrane potential of the mitochondria when there is an insult to our brains, and also reducing the oxidative damage and stress that occurs as a result of the insult. Other pathologies such as Alzheimer's disease and also Parkinson's disease show a very similar pattern. Therefore, when creatine is given to patients with both Parkinson's disease and also Alzheimer's disease, there seems to be a level of amelioration in certain tasks, especially in cognition, learning and memory. Out of 16 studies, 13 studies of these show an overall positive correlation between creatine and overall brain performance. However, the biggest problem is that most studies are actually very heterogeneous in nature. We have various studies where we have elder population versus a younger population, or patients undergoing a certain diet versus other patients undergoing another diet. And this creates a bit of a problem when it comes to the interpretation of the data. When it comes to mental fatigue, creatine also seems to play a role in reducing the mental fatigue, for example, during sleep deprivation. When creatine was supplied to athletes, elite rugby players, a group of 10 elite rugby players, under conditions of sleep deprivation where the players slept for around 3 to 5 hours at night, when they were asked to perform a skill-based task, for example, passing a rugby ball between themselves, when the players were supplied with creatine at around 50 grams 1.5 hours prior to the skill-based task, there was an amelioration in the task performance compared to the group that did not take the creatine, therefore showing that creatine might actually also be beneficial in cases when we are under increased levels of mental fatigue or mental performance. When it comes to mood disorders, depression and anxiety, patients that were given creatine, for example a group of females which were on SSRIs, which were supplemented with creatine, showed an amelioration in their mood compared to just taking the SSRI by itself. After 8 weeks of taking the SSRI and the creatine supplementation, there was an amelioration in the mood better than the group that were just taking the SSRI, and this showed greater effects on mood and positive effects at reducing the overall symptoms in this group of patients. In a similar experiment, when a group of elderly patients were given creatine compared to a group of young individuals at around 20 grams per kilo per day for around 7 days, there was an improvement in learning, completion of cognitive tasks. Therefore, the group of elderly patients showed a greater response to the creatine supplementation compared to the younger group, which were given the same dosing schedule over the same period of time. Therefore, this might indicate that as we age, our requirements for creatine might be greater than as we are younger. Of course, this makes sense because as you age, the way in which the brain makes creatine can change because, of course, there's a change in the metabolism of the brain as a whole. As we age, our metabolism changes, our requirements for energy also change, and therefore compared to the younger group, the aging population might need more creatine than the younger age group. Overall, creatine shows to have a positive outcome on mental health and brain performance, and although the studies are not always consistent, there's a great amount of heterogeneity in the studies. The overall results on creatine are quite promising, and creatine supplementation at around 5 grams per day over a long period of time might produce certain benefits when it comes to our brain health, mental stress reduction, and overall cognition. Especially for you students out there studying for exams or those people who are under conditions of severe mental stress, creatine supplementation at around 5 grams per day might help elevate the symptoms and also improve our overall mental health performance. I hope the video was interesting, guys. Thanks for watching this video and see you in the next one.